Triangle ABC with circumcircle T has side lengths AB equals 8, BC equals 6, and AC equals 4. Let D be a point on side BC such that there exists a circle internally tangent to T at A and tangent to BC at D. Let E be a point on minor arc BC of T such that the length BE is twice the length CE. Let K be the intersection of lines AE and BC. And let L be a point on BC such that AD bisects KAL. Then AK times AL is equal to M over N, where M and N are relatively prime positive integers. What is M plus N? This is triangle ABC, which has side lengths 8, 6, 4, and circumcircle T. We are about to add points D, E, K, and L. It is given that there exists a unique circle that is tangent to T internally at A and also tangent to BC at D. Based on this, there's a homothency centered at A that sends D to the midpoint M of arc BC. Hence, ADM is the angle bisector of BAC. It is also given that point E is a point on the minor arc BC, such that the length BE is twice the length CE. So we can let BE equal 2x and CE equal x. Then notice that in quadrilateral ABEC, it's a harmonic quadrilateral, meaning it's a cyclic quadrilateral in which the product of opposite sides is equal. AB times CE is 8x, and AC times BE is 4 times 2x, which is also 8x. Harmonic quadrilaterals have many important properties. One of them is that when we take this diagonal AE and let it intersect BC at K, then AK is known as a symmedian of ABC. It's the reflection of a median over the angle bisector. And BK over KC equals BA over AC squared. In this case, BA is 8 and AC is 4. So 8 over 4 squared, which is just 2 squared, and that's equal to 4. So BK over KC is equal to 4, and BC is 6. So we know that BK is equal to 4.8, and CK is equal to 1.2. Point L is a point on BC for which the angle bisector AD is also the bisector of angle KAL. In other words, AK and AL are isogonal, or simply reflections across the angle bisector of angle A. Then, since AK is a symmedian, AL must be the median, since the symmedian is the reflection of the median over the angle bisector. So, L is the midpoint of BC, and it follows BL equals CL equals 3. Now we can use Stewart's twice to find AK and AL, and then multiply AK times AL, and then we're done. Suppose we denote AK equals little k and AL equals little l. Then, using Stewart's theorem, with BK equals 4.8 and CK equals 1.2, we can find little k. We have, using Stewart's theorem of man plus dad equals bomb plus sink, we have 4.8 times 1.2 times 6 plus 6k squared. That is equal to 4.8 times 4 plus 8 times 1.2 times 8. And 4.8 times 1.2 times 6 is 34.56 plus 6k squared equals 4 times 4.8 times 4 is equal to 76.8, and so is 8 times 1.2 times 8. And this is equal to 153.6, so we have 6k squared equals 153.6 minus 34.56, which is 119.04. K squared equals 19.84. If we multiply k squared by 25, we get 25k squared equals 496. And so we have 5k equals the square root of 496, which is 4 root 31. So we have little k equals 4 root 31 over 5. And now for little l, we have 3 times 3 times 6 plus 6 times little l squared equals 4 times 3 times 4 plus 8 times 3 times 8. 3 times 3 times 6 is 54 plus 6l squared equals 4 times 3 times 4 is 48. And 8 times 3 times 8 is 192. So this is equal to 240. 6l squared is 240 minus 54, which is 186. We have little l squared equals 31. That means little l is equal to root 31. We want the product k times l, so it's 4 root 31 over 5 times root 31, which is just 4 times 31 over 5, 124 over 5. We want this to be expressed in the form m over n, where m and n are relatively prime positive integers. So m is 124 and n is 5. What is m plus n? It is 129. Thank you for watching my YouTube video, and please follow my channel if you would like to see more videos.